Let's apply what we've learned so that we can use z-scores to identify univariate outliers within a variable using Microsoft Excel. For this example, I am using the Depicting Distributions Week 6 Excel spreadsheet that I created and made available both in our class and through a link in the description for this video. Let's take a look at the data set and we'll learn about z-scores and univariate outliers. On the first tab of this data set, we see the dog toys data set, and I'll be using examples from dog toys. The example that we're going to use for outlier can be found on the Outlier tab. Click once to go there. This is where we're going to be doing all of our work. But if you'd like to see what it will look like at the end, you can click on the secondary tab. There's all of the answers and the formulas. Let's go back to the outliers. The first step is going to be to create z-scores for every raw score in this variable. And to create a z-score, we need three things. We need the raw score, we need the mean of the variable, and we need the standard deviation of the variable. We'll begin by creating that mean and standard deviation. The mean for toys owned is going to go in cell F4. And so that we can see this a little easier, I'm going to enlarge. To create a mean, we use equal sign, average, open parentheses, and the toys owned data are in column B. Click on the B, fills in the argument for this formula, and we get the average by clicking return. It is 6.08. Next, I need the standard deviation. That is equal sign, STDEV dot S, because I'm using a sample rather than a population. Open parentheses, only one argument needed. That's the location for the data. B:B, and return. There's my standard deviation. With the mean and standard deviation, I'm ready to create a z-score for each raw score in my variable. The first raw score is going to go here in C2. I'll use the standardized formula. Equal sign, STAND, there's standardize. And there are three arguments required: the raw score, the mean, and the standard deviation. Now the raw score is kind of hiding right now. It's actually in B2, so I'll just, not D2, B2, I'll type it. And I could reference the mean and standard deviation directly and create an absolute reference to them, or the standardized function will also allow me to type in these numbers, 6.08, comma, 3.75, close parentheses. And I complete the formula by clicking return. There it is. There's my first z-score. Because these z-scores are right next to the raw data, now I can click on C2, and instead of having to drag this formula all the way down, I can double click to copy it all the way to the bottom of my data. As I did in a previous video, I want to change these z-scores to only 2 decimal places, which I will do using this decrease decimal button. That was a little too far. There we have, just 2 decimals. And because I like the symmetry, I'm going to center this value. All right, great. Now, each raw score has a z-score attached to it. The mean is 6.08. Let's see if we can find a value of 6. Notice that the z-score is negative 0.02. It is just a small fraction, just 2/10 of a standard deviation below the mean. Any value less than 6 is going to have a negative z-score. Values greater than 6.08 will have a positive z-score. This 11 is 1.31 standard deviations greater than the mean. But the point here is to find outliers. Outliers can be defined in different ways. 2 standard deviations would be 1.96. 3 standard deviations would be greater than 3. So you'll see different recommendations for how to specify what is an outlier or not. Let me show you the technique that we would use regardless to find these univariate outliers. I could scroll through looking for values greater than 3 or 3.3. But to make this easier on myself, what I'm going to do is go to the data function and sort. I'm going to sort based on toys owned and go from values largest to smallest. Put the largest z-score on the top. Click OK, and there it is. So what I see is that dog number 126 owns 20 toys. The next highest value is a 14. The z-score for this value of 20 is a 3.71, which would definitely qualify it as an outlier in my data set. Now, if I leave that outlier in this variable and create a scatter plot with another variable, this outlier is going to exert leverage on my regression line. Essentially, it's going to change the slope of that line and weaken the model that I'm trying to create. Therefore, if I'm going to use this variable in some other analysis, I'm going to want to address that outlier. Now, I don't like throwing out data points, so I'm not going to delete the outlier. But what I can do is to Winsorize it. I can reduce it from its outlier value to a value that is in line with the rest of the data. Right now, 20 is an outlier value. The next highest value is 14. To Winsorize this outlier, I would move that 20 down to 15, 1 point higher. It is still the most extreme value in the data set, but it is now more closely in keeping with the other values. It is the next highest reasonable value. To Winsorize this outlier, all I need to do is go to the outlier, click on it, and change it to the next highest reasonable value of 15. Now note that this value, by changing this outlier, it is going to adjust my mean and standard deviations slightly, but I have now brought this extreme value down in line so that it is no longer an outlier and exerting excessive influence or leverage on my model. And that is how you identify and fix univariate outliers using Microsoft Excel.